Hi guys. So today we're going to do our first video lesson piece. So you need page 18. So we already did the double replacement. So our precipitation reactions where we figured out whether or not a solid formed, and then the acid-base neutralization reactions. So now we're on to single replacement. So this is where we're going to use table J. So make sure you have your reference table with table J. And remember, this is the listing of metals and nonmetals, most active being at the top, least active being at the bottom. So anything that's above something else is going to be able to replace it or be cute enough to steal its girlfriend. So for example, these two that are circled, magnesium would be able to replace zinc in a compound, but vice versa, zinc would not be able to replace magnesium. So there's an example on page 19. So single replacement reactions where you have an ion that's separate by its place is going to be replaced by something that's bonded. So you have a bonded compound like silver nitrate. So here's your metal and your non-metal portion. And then copper is a metal. So metal would have to replace the metal. Just that's the way ionic bonding is. So in order for copper to be able to kick out silver and steal the nitrate, copper would have to be more active than silver. So if we go over to table J, you can see copper is not very active, but it is more active than silver. So this reaction can take place. So copper kicks out the silver and bonds with the nitrate. Copper has a +2 charge, nitrate is -1, so that's why it's CuNO3 2. And then the silver now is by itself with no charge. This is just a piece of silver, so that's why it says silver solid. So we'll pay more attention to the states now than we would have before. So you have solid copper, you have a silver nitrate solution. So if I put these copper wire in the silver nitrate, now I'm going to have copper nitrate and pieces of silver. So in other words, this would be like a blue liquid, and this would be just a silver solid metal. Okay. And it's able to happen because we refer to table J. Okay. So if we looked at it from an ion perspective, we have copper solid, so that would just be Cu with no charge because it's a solid piece of copper, it's not an ion. We'd have silver, so we'd have two of them, so it'd be 2Ag + 1, and then 2NO3 - 1, and those are both aqueous, so we'd have Aq and Aq. Then we would have copper with a +2, we'd have 2 NO3s with a -1 charge and aqueous, and then 2 silver solids. So again, it'd kind of be like the net. This would take apart. We'd have solid copper, silver ion, copper ion, silver solid. So we'll do more of this in the next coming days, but this is the piece that you guys are going to practice today. So you guys need to get the single replacement worksheet, and it's actually single replacement number Roman numeral 2. So it looks like this. So if you guys want to stop the video, make sure you go get that, and then we'll look at a couple of these together. So make sure that you have the one that says single replacement 2. All right, so if we look at the first one, it's just like what we just saw in the video. So if copper is going to react with silver nitrate, copper would have to be more active than silver. So we refer to table J. So when we go to table J, copper is here, silver is here, so copper can replace silver. So now the copper is going to be with the nitrate. Copper's +2, nitrate's -1, so we have to do CuNO3 2, and now the silver has been kicked out and is by itself. This is going to be aqueous, and this is going to be solid. You don't have to do the whole net ionic. Then if you look at the second one, now we have silver wanting to replace copper that's combined with sulfate. So silver is the metal, so it would kick out the other metal. But when we look on table J, silver is not more active than copper. So this would not be able to happen. So this would just be a no reaction. Okay, so you guys are going to go ahead and finish these. Remember to check whether it's going to be no reaction or whether it's going to take place. Make sure that you write the compounds correctly, and then, balance them. Balance the reactions that actually do take place. So remember that this isn't just going to be CuNO3 necessarily, it's going to be combined. You're going to have to look up the charges. Okay. And then you'll answer question number 9. Okay? All right. Hope you guys are doing well. Miss you. Bye.